Our topic today is exception handling. Let's get to the code. Create a new project. Call it exceptions. Add the class main and create a program entry point. We will work here today. Create an int variable a and assign it the value of 0. Now create an int variable b and assign it the value of 7 divided by a. Then we will print out the line hello. Run the program. And we can see a red line but not the word hello. Why? Firstly, we know that we cannot divide by 0. And when the program tries to do it here, it encounters an error. Using the correct terms, this is an exceptional condition or simply an exception. Exceptions are normal when the program is in the development because the program fails. But if the project is complete and the program is bought by the customers, they will be very disappointed by a fault of the program. Let's take a look at the log to see what was the mistake. Here we can see the words arithmetic exception, division by 0. So what should we do if an operation is required? But we know that this operation might provoke an exception. For example, here we can divide not by 0, but a number supplied by the user, and the user made a mistake of entering 0. In this case, it is not desirable that the program would fail. In order to avoid this situation, we can use the construction try-catch. To do so, we must write try before the code line, which might result in an exception. Our code must be in the curly brackets. The try block must be concluded by the word catch. Soon I will explain what this means. We must specify an error type in the round brackets. Here it is, arithmetic exception. Let's copy this and paste it here. As such, an exception is an object of the exception type. In this case, it's an object of the arithmetic exception type. We must give it some name. Usually it's called E. Open curly brackets. Here the program will run, the variable a will be assigned the value of 0, and then the program will attempt dividing 7 by 0. If this all results in an exception, the actions which are listed in block catch will be performed, and the program will not fail. It will continue operating. In case of an error, let's print out you can divide by 0. Run the program and see these words. You can divide by 0. And the word hello is displayed too. It means that the program has not crashed. It tried to divide by 0, an exception arose, and it was of the arithmetic exception type. And then we caught the exception of this type in the catch block. So the code we needed was executed too. And then the program proceeded its operation. So what is an exception type? We already know what inheritance is, what superclasses and subclasses are. So all the exceptions have a superclass called exception. A lot of various subclasses of exceptions are derived from this one. In this case, if we try to divide by 0, we can see the exception called arithmetic exception. Do you remember how we converted a number into a string? Let's try to do it here. Create a string and assign it a value which contains numbers and letters. Now let's try to convert the string into the int type and assign this value to the variable I. To convert a string into a number, the static method parseInt must be called for the integer class and accept our string. Run the project. Everything is printed out correctly, and this is why it happened. We tried to divide number 7 by 0. An exception arose. All the rest of the code in the try block was ignored. The catch block caught the exception and displayed you can divide by 0, and then the program continued to operate. Let's assign the value of 1 to the variable a and run the program once again. And this time again, we're having an exception, but of the number format exception type. Although we have put the code for converting in the try block, we have not handled the exception of this type. To handle an exception of this type as well, one more instance of catch is required. Write catch, and in the brackets, number format exception. We will call it E1. The name doesn't make big difference. We will print out conversion error. Run the program. Now there are no red lines. The program has not failed. The line conversion error was printed out, and the program continued to work. It displayed the word hello. If we change the value to 0 and run the program, we will get the message, you can't divide by 0. It means that all the actions in the try block are performed consecutively. And once an exception appears, the execution of this block is terminated, and the catch blocks start being executed. In the first case, it was an arithmetic exception, and the first catch caught it and printed out you can't divide by 0. The rest of the code was skipped and the line hello was displayed. If we divide by 1 here, the code continues to be executed until the line where another exception arises. This exception is caught by the catch, which contains number format exception. So the line conversion error is displayed and the program continues its operation. And what if we do not want to catch specific errors? We do not care what type they are. An exception arises, we must catch it and go on. As I have said, all exception types are derived from the exception superclass. Thus, unless you want to take different actions depending on the exception type, you can simply define their parent type. Let's delete this all and write catch, and in the round brackets, exception. Call it E. We can refrain from printing out anything in the catch block. Run the program and the word hello is printed out. If we change the value of the variable to 0 and run the program, we will still have the word hello printed out. Now, regardless of the error type, an exception arises and is caught by catch in any case, because it catches all the exceptions of the exception type. But if we want to catch some specific exception, for example, arithmetic exception, we will write catch arithmetic exception E1 and open curly brackets. And we will have an error, because when an exception arises, it will be caught by the first catch. This exception will never reach the second catch. So our error here is exception has already been caught. If we still want to catch the division by 0 and ignore all other exceptions, we can simply swap them. The first we will try to catch will be arithmetic exception, and only then general exceptions. Let's print out you can't divide by 0. In the first case and in the second, we will do nothing. Run the program. We have the message you can't divide by 0. Change the value to 1, and we will have the word hello alone. Now all the exceptions that arise, except the arithmetic exception, will be caught by the catch block with the general exception defined. But if the error of division by 0 occurs, that is the arithmetic exception, it will be caught by the first catch, and the message you can't divide by 0 will be displayed. And now I will show you one thing which is good to know, because you will need it in the future. Now it's hard to think of how this can be used, because it's utilized mostly in the work with threads, reading data from the internet, from the files, or writing to files, and so on. Just remember that this can be used. Write finally after the last catch and open curly brackets, and let's display the line we are in the block finally. Run the program. You can see that the line was displayed. Now let's delete the string conversion. It means we will have no exception here. all catch blocks will be skipped. Run the code, and we are still in the block finally. Whether an exception arises or it does not, the block finally is performed anyway. And the reason for this block is the following. We have opened an internet connection. We are reading data from it. And then we close the connection. But if some error occurs during the session, we will still need to close the connection, independently of whether we have read the data or not. This is why the command to close the connection is located in the finally block for the connection to be closed, if the data was read successfully or not. Our homework is as follows. Try to create an exceptional condition when an index out of bounds exception will arise. It's the situation of array overrun. We have encountered it when studying arrays. It arises when we try to address an array element which does not exist in the array. For example, an array has 10 elements, and we try to address the 11th or -1st. Handle this exception in the try-catch block and print out the message, array overrun. Good luck and see you in our next lesson.